Right. So our next experiment is this bifilar pendulum. Determination of moment of inertia. Moment of inertia. Okay. So what is moment of inertia? What is inertia? So an object that is in rest will be in rest forever. The object in uniform motion will try to be in uniform motion forever. So the control parameter is inertia. So coming to linear motion, so when the object is moving in a straight line, what is that responsible for inertia? So inertia ante emanunamante, the object in rest will remain in rest, the object in motion will remain in motion. Okay, so let's say you are trying to start a small vehicle. ఒక చిన్న స్కూటీని స్టార్ట్ చేద్దాం అనుకున్నారు, స్మాల్ స్కూటీ. So you can rise it very quickly, and if you apply brake, it stops very quickly. Whereas you have a very heavy truck, ఒక 10 tons, 15 tons, otherwise very heavy capacity, heavy load truck ఒకటి ఉంది. When you try to rise its speed, it rises very slowly, and when you try to stop it, it stops after a long time. Right? So what is the control parameter for inertia? Inertia and control is the mass of the object is the control parameter for inertia. So here is the mass, here is the inertia. Okay. So if you try to stop a very heavy vehicle, it takes longer time. And if you try to rise the speed, then also it takes longer time for a heavier vehicle. So that is about linear motion. So inertia takes care of linear velocity or linear acceleration. Okay. So coming to moment of inertia. Moment of inertia it deals with rotatory motion. Okay, how better you can bring an object into rotatory motion is given by moment of inertia. So moment of inertia is usually mass times square of the radius. So if you are taking this rectangular object, let's say, it is m times x square plus y square by 12. So if you are taking this as x direction, some x direction, this is y direction, other thickness is z, let's say, then the moment of inertia in xy plane is m times x square plus y square by 12. Okay, and Iyz is m times y square plus z square by 12. Izx is m times z square plus x square by 12. So that is the moment of inertia. So what does it tell? It tells information about how better you can bring an object into rotatory motion, or how better you can stop an object that is already rotating. Okay, ఒక రొటేటింగ్ ఆబ్జెక్ట్ లేదు, ఒక స్టేబుల్గా ఉన్న ఆబ్జెక్ట్ని రొటేటరీ మోషన్లో తేవడానికి ఎంత ఫోర్స్ కావాలి అనేది మొమెంట్ ఆఫ్ ఇనర్షియా చెప్తుంది. సో దిస్ మొమెంట్ ఆఫ్ ఇనర్షియా డిపెండ్స్ ఆన్ వాట్? ఇట్ మాస్ ఆఫ్ ద ఆబ్జెక్ట్ అండ్ ఏరియా ఆఫ్ ద ఆబ్జెక్ట్. So higher the area, higher is the moment of inertia. So if the area is very high, moment of inertia is very high. Okay, Nandi? So elaga, how to decide that? Let's say you are trying to rotate a plate. A plate తీసుకోండి. When you try to rotate it, ఏ ప్లేన్లో ఈజీగా రొటేట్ అవుతుంది? సో టేక్ ఏ ప్లేట్, ట్రై టు రొటేట్ ఇట్. ఇలా తిప్పడం ఈజీనా, ఇట్లా తిప్పడం ఈజీనా? ఓకే, when you try to stop a plate, already rotate. It is already rotating and you try to stop it. Which way is easier? ఇలా ఉన్నప్పుడే కష్టం అవుతుంది. It is difficult to stop the plate which is rotating, which has more area. More the area, more difficult to stop it. More the area, more difficult to bring it into rotatory motion. If you have small wheel, you can rotate it easily. If you have big wheel, big plate, it takes more energy. Right? So more the area of the object, more is the moment of inertia. Okay? So now we'll verify that. So here Z is negligible, right? So here X is, let's say, so let's say the length of this slab is 9 centimeters. 14 centimeters. So X is 14 centimeters.
Y is 9.
Y is 9 centimeters. Z is 1 centimeter. Okay. So for this metal slab, X is 14 centimeters, Y is 9 centimeters, Z is 1 centimeter. So Z is almost negligible. So now, I mean, if you ignore that, what can we write? I xy is equal to I yz plus I zx. Right? So what is that? X square plus y square? 14 square plus 9 square. Okay, ignore those numbers. Some number. Here it is 14 square plus 9 square plus 1 square. This is 1 square plus 14 square. So if the third direction is negligibly small, you can write Ixy is equal to Iyz plus Izx, nearly equal. Right? Xs is what? 1 plus 1 only, the extra quantity. So that is what we are going to verify in this experiment. So the moment of inertia along xy plane is equal to sum of the moment of inertia along yz plus xz. Okay. Right. So when you tie it to a rigid support along a particular direction and try to oscillate it. Okay, so this is in YZ. Now I am considering YZ direction. This is 9 and this is 1. So this is the plane I am considering now. YZ plane. 9 centimeters and 1 centimeter. On the top, this is the plane I am trying to rotate. I am trying to rotate the YZ plane. So now this time period is given by, what is the time period of pendulum?
Completely on station.
It is 2 pi root L by G. And here we have 2 strings attached to it. And we are trying to see the moment of inertia, which is mass times area. Right? So this formula changes to T is equal to 2 pi root IL by mg d1 d2. Okay. So here, let's say so this is the suspension we have. L is the perpendicular length. L is the perpendicular length, and this is D2. This is D1. D1 is the separation between hangers, top hangers. D2 is the separation between these bottom hangers, these two. D1 and D2. So what I am doing here, I am considering moment of inertia into this formula. So which is mass times area, mass times square of some length. Okay, so I am dividing with mass here, and I am dividing with two distances D1 and D2. So I am introducing I and dividing with M D1 and D2. Okay, so this is what the total formula is. So what happens? More the moment of inertia, more is the time period. Okay, so that is what we will verify. So we will tie it to a rigid support. We have to measure the separation between the top hangers, that is D1, bottom hangers separation D2, mass of the slab, it is around some 450 grams or what, we will check it, and length is a perpendicular distance, so from center to center, from the center of the bottom hangers to center of the top hangers. Okay. So what you have to measure? You have to measure the time period. So time taken for, let's say, 20 oscillations. So if you start counting from this end, let's say if this is 0, 1, 2. So like that you have to measure the oscillation time for 20 oscillations and divide it by 20. You get time period. So so from here I is what? T square by 4 pi square. T square by 4 pi square. mg d1 d2 by L. So this is the value of I from your experiment. This is the value of I from your dimensions of the object. So you have to measure IXY, IYZ, IZX from the dimensions of the object and compare with the experimental results. Okay. So done. We'll see that experiment. So what is the table for this experiment? So you have to write for 3 cases you have to do IXY, IYZ and IZX. For the first case, value of X, value of Y, and whatever dimensions we have, and calculation for I. And then experimentally you have to fix these values, right? What are the values? L, D1, D2, then time period. T20 first time, T20 second time, T average and T. Then calculation of I. So we have 2 parts. So I x y, I y z, I z x. Here x, y and I, one set. Another set d1, d2, L, t20 first time, t20 second time, t average and t. Then calculation of I. Using this, m value is outside. M value, G value are outside. Okay, and you have to verify this. Ixy is equal to Iyz plus Izx. That's the table form.